let me join the conference organizers in welcoming you to this attempt to launch Alberta's presence in analytics, big data in the cloud. We are capitalizing on a number of amazing trends that I'll talk to you about. Deloitte is happy to be a sponsor of this event, and I'm looking forward to sharing with you some results that we have from looking at analytics and big data. I thought, given my experience with the driver, should define some terms. What do we mean by big data? Because there are a number of different definitions out there. One person I've talked to says, big data is anything that doesn't fit into my spreadsheet. So I bet he's really happy that Microsoft Excel no longer has that 66,000 line limit, and now he can go up to 1 million rows. But we think of big data considerably broader than that. I want to talk about some case studies. Case studies, I want to focus on healthcare, on social services and energy as picking some areas that are of interest, I think specifically to Alberta, although I should tell you that, and maybe we can address this in a Q&A, I've done a lot of work around retail and banking as well. There's a lot of promise, but there are also challenges. I want to talk about challenges not just on the technology front, but also around policy, governance, the people. Where do you find the people that can do big data? I've mentioned that as well. And then, don't want to leave on a down note with all the challenges there, give you some tips for getting started. How do you get started in realizing the promise of big data? So big data, there's a definition up there which builds off of something you can find on Wikipedia. But sometimes big data is one of those things that you'll know it when you see it. Definitions don't work so well. So I thought I'd start with an example. Here's a client that we're working with, eBay, that really does have big data, no matter which way you cut it. They have over 100 million users, 2 billion page views daily, and by sheer volume of information, the slide says 20 petabytes because that is what you can source off of GigaOM, but I know that their data store now, Teradata's largest customer, has over 34 petabytes in it. And it's rapidly growing. And it's growing, the amount of data that clients like that have to deal with is growing so fast that they've now coined new words to describe big data. You've heard of exabytes, which is 1,000 petabytes. There's zettabytes, which is 1,000 exabytes. And there's yottabytes, which is even bigger than that. And that's even, at this point, they estimate that the amount of data in the world is around one zettabyte. And so yottabytes is something we can barely conceive of at this point. It's not just about the size of the data, it's also about the velocity, that is the rate at which data is being generated. And there are a number of statistics that one can throw around. Here, in this case, they're growing at over 50 terabytes per day. There are other statistics. Walmart has over 1 million transactions per day. Zynga, the online gaming, like Farmville, Mafia Wars, and so on, is reputed to move about 1 petabyte of data a day. And what all that means is that the old algorithms for doing analytics that are batch, that assume that your data is static and then you run it and then within a few seconds or minutes you're going to get the answer, it's not going to work in this scale of data. You need data and algorithms that can run on the fly and adapt to new data as it comes in. And finally, the big challenge, take these 3 V's. Gartner has been referring to this for a while now, and we've adapted it for our purposes. Variety. If you look at the kinds of data that eBay does, it's not just who bid on what items on the auction. It's their CRM data, which customers are engaged, social media, what are people saying in various forums about eBay. It's images of the items that are for sale, for which they use big data techniques like Hadoop to actually do image similarity on those data. And an incredible variety of data that organizations, whether it's public sector or private sector, have never really tried to integrate before. And we find that actually the variety of data is the biggest challenge that our clients are facing out of the 3 V's. So I thought I'd talk a little bit more about that. Talk about the spectrum of data from structured data, traditional structured data such as you might find in your ERP systems, transactional data like company financials, bank accounts, employee records, and so on. Those are the traditional records that are legacy data, traditional data. As you move out on this chart, up and to the right, data gets more complex and data gets larger in scale. So things like movies, click streams, mining interactions to understand what people have been doing online and getting insights into your behavior, even to the point where video, surveillance video from stores that they use to track shoplifters and used for security purposes are now being repurposed to understand what is the pattern of behavior as customers go through the store, what do they look at, what do they eventually buy. And using the video that was originally created for something completely different to now get insight into customer behavior. That is the possibility of big data. So let me talk about the evolution of data, because you'll hear big data often described as a revolution. And it is in the sense that there are unprecedented opportunities, but it is not something that is completely different that organizations have never dealt with before. Because in fact, if you go back in history, for decades now, organizations have tried to manage their data to make better data-driven decisions. They put in place data standards, they integrate data from multiple sources, they do reporting on it, they introduce business intelligence systems that then allow you to slice and dice the data and get good insight to what has happened historically. When they get more advanced, then they start doing data analysis and try to figure out what factors are correlated with what other factors. And the reason for doing that is to try to figure out why something happened. Not just what happened, but why it happened. And then as they get more advanced beyond that, maybe they'll have some optimization tools, some modeling tools, and then they start to do predictive modeling. What could happen, or what should happen? What's the best that can happen? So they'll use tools like SAS and SPSS and now R to do modeling. And then you put that in a real-time environment, like in a call center, where the agent who's talking to you has to know what bundle of products to offer you that you're most likely to buy. You need real-time response. And you take it even more extreme in a trading environment. In a trading environment, milliseconds count. That's the edge in which traders, so real-time response and the velocity, that's actually been there before. What's new is that all of these, the predictive analytics, the velocity of data, the variety of sources, all being combined, that's the challenge of big data. But we don't just do data, collect data for the sake of collecting data. It's the analytics that are on top of it. And the new techniques that are emerging in big data respond again to the volume, velocity, and variety. There's data manipulation because you have such large data stores. If you think about it, if someone hands you a petabyte of data, how do you open that file? I mean, it's not trivial. You can't just open it in Microsoft Excel or Word or anything like that. How do you deal with that? There are algorithms for analysis. So beyond the batch, going to the real-time incremental analysis, things that scale in sublinear time. And then the best models in the world don't work unless people act on the results. So you have to make the results compelling. You have to make them actionable. And the whole, we talk about it in shorthand here, is data visualization, but it's the interface to those models that becomes very critical. And then there are enablers under that: technology, process and controls, and talent. So the analytics, again, are not a mean, they're just a means to an end, not an end in and of themselves. People are trying to answer the questions in a broad range of functional areas that they've been traditionally asking, but now asking it in a way that is more informed by data. So we're seeing this in 5 or so functional areas. And these are finance. So like the chief financial officer is looking at costs and revenues and trying to identify risks. We're seeing it in workforce. So a chief human resources person is looking at how do you attract talent, how do you retain them, how do you promote them so that people will take advantage of the skills that they have. and how do you deal with a retiring workforce and changing demographics. So chief talent officers are looking at workforce analytics. Another functional area is supply chain. So chief operating officers are looking at where are the risks in my supply chain? How do I get a handle on pricing? How do I look at where I source material from and whether there are political risks that I should be aware of that might disrupt the sources of information? So that's supply chain. Another one is risk, and obviously the chief risk officer is concerned with how can they get early warnings of threats to the performance of the business, whether they are strategic risks, reputational risks, operational risks, all things that the chief risk officer is concerned about. And finally, there's consumer behavior. So that's the fifth of the domains. And the chief sales officer, the chief marketing officer, they're all in charge of looking at understanding from the data, how do I get better insight into what my customers are doing, what they want, what they're likely to buy. So a retail example that we've done, we're looking at which customers tend to eventually become high-value customers. Because high-value customers are obviously responsible for a large percentage of their high-margin purchases, and you can segment customers at a certain point in time, but how does those segments, how do they evolve in time? Which stores do people visit? What do they buy? You find things like if people tend to buy on sale, and you attract them, you get them into the stores, that's great, but they eventually don't buy things that are off sale at a normal price. So you've got to balance what is the cost of attracting a new customer with sales and investments to what you're willing to invest to create high margin customers. So those are some of the things that, the crunchy questions as we call them, that various leaders in organizations are concerned with. We call them crunchy questions because they are specific enough that if you answer them, you can act. And it's also crunchy because there's data there that you can crunch on and crunch the numbers to get the answers. So that's enough with the abstractions. Let me now go to some case studies. And as I mentioned, I'm going to talk about healthcare, I'm going to talk about energy, and I'm going to talk about social services. So for healthcare, let's start with one that we've been working with a number of hospitals on, a significant problem in the US and we believe also for Canada, and that is preventing avoidable hospital readmissions. It's very significant. It turns out that almost 1 in 5 people who are admitted to a hospital are going to be readmitted within 30 days, often for the same disease, the same thing that they came in with. And the biggest tragedy of this is that so many of them are preventable. You see the 90% number up here. 2/3 of those are actually due to medication interactions that could have been detected had the right review been in place because people didn't know what other medications that they were getting. In the US, these unplanned readmissions cost about $16,000 a piece on average, and if you multiply it out, that's a $42 billion problem in the US. So if we could address this problem, there would be the obvious benefits of improving the quality of life for the patients so they don't have to go back into the hospital, lowering the costs for the hospital. But now the hospitals actually have a direct incentive to reduce readmissions because starting in 2014, the law is going to require that the amount they get paid for Medicaid and Medicare is going to be tied to their ability to reduce readmissions. So that's a direct incentive to improve the quality of care so that they don't get readmitted. So what do we do to study this problem? We looked at a number of data sources, and it's interesting, in the US we're actually behind a bit in what we see in Alberta, because in the US we had to work off of administrative data, basically insurance claims, billing data, insurance, because we don't have as many electronic health records out there. And I understand in Alberta there's actually far more adoption of health records, and so you should theoretically be able to do a lot better than we did, because we had to do a lot of munging of data, again, like in the introduction, data that other people had given up on. They would never have thought that we could pull this data out. But this is the kind of thing we looked at: inpatient data, outpatient data, and pharmacy data. We did some extract, transform, load type stuff on it to load it into our data warehouse, derived some features, and then we created some dashboards, some reports, and I'll show you some examples of that, as well as a model that predicts a patient's risk of readmission, which gives physicians a capability for monitoring patients and treating them differently and intervening if they see that are a high risk that they've never had before. So here are some model variables that are listed up there. The real model at this point has some 72 variables in it, but there were hundreds, there were thousands that we could consider. And some of the art is actually how do you figure out which are the right features to pay attention to in your model. So this is one of the dashboards that we created, and we created it with specifically the view of the hospital administrator in mind. They're concerned with the overall trends. What is causing readmissions in my hospital? They want to understand, if you break readmissions down by different factors, where are the pain points? So here you see 4. There's the age. So readmission varies by age. There's the diagnosis that the patient came in with. There's the length of stay. How long have they been in the hospital, and how does that influence their likelihood of being readmitted, as well as the drugs they're taking, because certain patients on certain drugs and certain mixtures of drugs are more likely to be readmitted. Let's take the age one. You see a curve there, that's the one in the top left. And you see the same general trend at all the hospitals. Readmissions tend to be fairly high in the early years of life, and they go up to the teenage years. And we don't have an exact explanation for the teenage years being so high, but it's basically, we figure it's that once the teenagers get dismissed from the hospital, you tell them, you know, take it easy, heal, don't do crazy things. They don't listen to those instructions. So they tend to come back. And then readmission rates drop off as you go into your 20s and 30s, and then they start to creep up again. They start to creep up until you get to 65, and then they drop back down. Anybody know why readmission rates would drop back down when you get past that? I think somebody mentioned it, the patients start to die then. When it's serious, it's not that they're getting healthier, it's that they die before they get readmitted to the hospital. So we have an interesting case study. We did this kind of analysis for one hospital, and we found a spike in readmissions for 10 to 12-year-olds where we wouldn't have seen that before. If you analyze, tens of thousands, in this case, 250,000 patients for this hospital, and looking across all the records, comparing it to national trends, you can see where a spike in 10 to 12-year-olds that you wouldn't have expected is now statistically significant. And it turned out they traced it back to appendectomies. And 10 to 12-year-olds were going through these appendectomies, getting infections that drove them back to the hospital. As a result of this work, we were able to improve their care during their stay, some discharge monitoring, post-discharge monitoring after that, and as a result, fewer kids are going back to the hospital. They're healthier because of this work. That's one of the things that helps me get up in the day and do this kind of work. But there's more. So now think about the individual physician who wants to understand, well, I don't want to know overall trends. I want to know if my patients are at high risk for readmission. So we built them a model, a predictive model, using an algorithm out there called C5. That was a decision tree. And a decision tree, for those who don't know it, is basically, think of it as a series of questions that allows you to get progressively more detailed so that you can classify a given instance, in this case a patient, by whether they're going to be at high risk of readmission or not. And here's an example of a segment on the right side. You start with a patient who maybe has a diagnosis code of 144. If they have that code and they have very high hypertension, the combination of those two factors makes the readmission go up to about 0.97%. If they don't have high hypertension, well, you ask some more questions about their renal failure, hypothyroidism, and so on. You get that classification. And when you get a lot of cases and a lot of variables, then the decision trees tend to get really big. And what you see actually in the lower left is kind of an overview of a consolidated decision tree. There are 20 sub-trees that went into producing that. Now, we won't say that decision trees are the best way for coping with big data, but we chose this because our target audience, the physicians, were very comfortable with this. They understood, based on the questions that we had asked, what they had to look at in order to reduce the patient's risk of readmission. And with them, we designed a dashboard that looked like this. And the dashboard tells, so let's use the example here. We have a 46-year-old female who is admitted to the hospital for heart failure and shock, and she has an 83% propensity for readmission within 180 days. That's obviously pretty high. The doctor wants to understand why. At a glance, they can see the claims that have been filed on behalf of that patient over the last 180 days with different color codes for different kinds of episodes. In this case, the patient has a history of psychoses, substance abuse, and so on. And to understand how those contribute to the diagnosis of a high propensity for readmission, you can look at the factors that are listed on the left side, where psychosis is actually at the top of the list. Psychosis, the particular diagnosis code of heart failure and shock, the fact that there was emergency room visit. These are all factors that contribute, and so you can see not just why the patient was flagged for readmission, but how, what led them to that, why they were flagged. And then, beyond that, if we go back to the hospital administrator's point of view, now that they've got such detailed records and predictions based on particular patients of who's going to be readmitted, they can do something even more amazing, is that you can figure out, as an administrator, what is the optimal number of patients that you should assign to a readmission intervention program. So just because you identify a patient at odds for readmission doesn't mean you've solved the problem. You now have to reduce the risk factors. And you can put them in a program, a managed care intervention, that then offers them counseling, that offers them maybe post-discharge visits, social worker visits, and that kind of instruction. And that obviously costs money. So you don't want to do an unlimited number of interventions. And together with a few assumptions, the assumptions being things like how many patients do we have of certain type, how often does readmission intervention work, how much does a readmission cost, how much does a readmission intervention program cost. You can figure out the optimum because of the shape of the curve. The optimum number of people to intervene for is at the top of that curve, the peak of that. And there are two different hospitals. The lower one in the blue is actually an inner city hospital with a larger proportion of younger patients. And the more suburban hospital with a larger proportion of more senior patients is the green one at the top. And so what's important is not the exact numbers here, but the fact that we can do this at all. What we've just done using big data is create a business case that's tailored to the hospital that tells them how much money they're going to save by instituting a readmission prevention program. I don't know of anybody else that can do that kind of thing. Because if they intervene in more patients than are indicated at the peak, then they'll intervene for patients who were not going to be readmitted to the hospital anyway. They're essentially the false positives. That's the kind of analysis that you can get by combining this kind of data. So that's for my healthcare study. I want to go, because of the prevalence of government, and I'm giving a version of this talk to the CIOs of Alberta later today. They are interested in how can we help with social services. So the environment that public sector agencies now have to operate in is very demanding. They have to rapidly respond to regulatory reforms. They have to do more with less. They have to basically ensure that they're getting the maximum use of the resources while minimizing the risk. They need to operate in those workforce conditions, competing with the private sector, an aging population in certain sectors. How do they recruit people? How do they promote people? All of those concerns that any human resources officer has to deal with. They have to figure out how they can get every dollar that they're entitled to, whether it's in taxes or in child support or anything else. They have to reduce fraud, waste, and abuse, which is a case study that I'll talk about in a second. And finally, using the same sorts of techniques I just talked about with the hospitals, they have to use predictive outcomes. So something that we've done for a number of states in the United States is work with child support enforcement agencies to identify those non-custodial parents, non-custodial parents who are at high risk of becoming delinquent in their child support payments. Generally, deadbeat dads is the shorthand for that. And the reason, if you can identify them, you can do outreach to them and then be able to make sure that their risk factors are mitigated as much as possible. And in one case, at least one state was able to get over 80% collections, which had been unprecedented in every state, of the child support payments that were required to be filed were actually filed for use of this kind of intervention. But I now want to shift to the fraud, waste, and abuse one, particularly because it involves an easily grasped visualization that that shows the results of analytics. So the application here is one for childcare reimbursement. Somebody files and says, I've got daycare expenses, I want to get paid back by the state. And in order to do that, they have to file 3 addresses. They have to file where they live, they have to file the address of where the daycare facility is, and then they have to say where they work. Generally, you would expect those to be in the vicinity of each other, or at least on the way to one another. But what you have in this case, from the state of Pennsylvania, a applicant who lives in Palmerton, Pennsylvania. Theoretically, according to their application, the daycare center is 55 miles away to the north in Scranton, and then they go to work 71 miles south in Allentown. So that total trip would be 2.5 hours if they were actually doing that every day. The question you got to ask, is this reasonable? Is this a reasonable pattern of behavior given that there are child care centers in different places? And you might say, well, that is suspicious, that's true, but how often do you come across those things? Well, in a database of several tens of thousands of cases, this showed up over 300 times. So there's patterns of behavior that you definitely want to find out about because they have such high potential for reducing fraud, waste, and abuse. That's an example of what we call geospatial analytics. And what's the big challenge in that? The big challenge in this is not doing the algorithms to figure out what travel times are. It's actually cleaning up the addresses. Because the address data that gets filed by all these, I mean, there's like, I think we detected some 75 ways to spell Philadelphia that was on these things. You got to normalize them all to the same, to the same city. And, but there are techniques to help with that. There's technology to do that. And that kind of technology, dealing with unstructured data and semi-structured data, is going to become very important. As another example of that, you can look at the addresses themselves and see if they're suspicious. In 5 cases, there was a single address used as a home address. The problem being that where that address was, there were no homes there. It was a non-residential area. Google Earth makes this real easy. You don't have to invest a lot of money in order to start with big data. You can use things like Google Earth. In another case, you can join it with other data. For example, the list of suspected frauds. And there was one address in which somebody had been known to commit fraud. And within the neighborhood, right next door in some cases, there were a tight cluster of neighboring cases where people had applied for that. And that doesn't make it suspect. Just because one person commits fraud doesn't mean that all their neighbors are going to commit fraud. And it's kind of profiling, but it's something, it's a risk factor, something to look into. Again, geospatial analytics at work here, and actually leading to some real fraud investigations. I'm going to spend a little less time in this last area in the interest of time here, but I don't want to pass up, especially given all the oil sands in Alberta, the opportunity to talk about energy management. Energy is a great area for big data because no matter who you are in the spectrum and the whole value chain, whether you're a policymaker charged with compliance or trying to influence consumption patterns, whether you're a provider of energy, looking at what your sources are and what your supply options, what does the supply chain look like. Whether you're an investor looking at financing options or tax implications, very important in the energy space, or you're a user and trying to minimize your consumption of energy through the use of smart meters, there are always opportunities. All these questions are just a sampling of energy possibilities. We will take the point of view of a consumer based on some work that we were doing with a large chain of restaurants trying to minimize its energy consumption. And here the restaurants are primarily located at various places in the United States. And in order to compare apples to apples, you have to factor in weather patterns. And in this case, looking at air conditioning costs, it was cooling degree days, which obviously increase in the summer months, driving cooling load and electricity consumption. As you might expect, facilities in the south and west have the higher cooling load due to the hotter temperatures. You factor that in and then create dashboards like this one here, which gives you the facilities that are both the top consumers of energy in absolute terms relative to the expectation of them, as also which one is changing faster. And it's an interactive dashboard, so if you hover over it, and don't do the demo over here, but you hover over it, you can get more information about that particular sector. And this has been something that is of great interest to clients that have a large number of facilities. And just so you know, we're not just doing analysis in the United States. Little local flavor here. We worked with Canadian electricity data and are trying to project price increases by year-end 2020. And some amazing differences come out. You know, nationally, the prices have been rising at about 0.36% per month since 2000. But if you look at individual provincial trends, there's huge regional variations. In this case, Alberta and Ontario are pretty much at the top of the projected price increase. And it's a little hard to see. The only green one with the low one is in Prince Edward Island. And the reason for that is that they primarily use wind energy and a number of non-renewable sources. So if you're looking for low-cost energy, maybe that's a good place to relocate to. I don't know. But with Alberta, what we looked at was capital investment requirements, aging facilities, and what costs were going to need to be passed on to consumers of electricity in the rate structures, as well as operating expenditures. It's an Excel spreadsheet, not a huge deal to deal, not very sophisticated analytics. But I'm told that when we present these kinds of results, and in discussions with companies in Canada, the discussion just keeps on going. You can, so there's a lot of possibilities for tapping energy sources of data. I want to talk a little bit about the challenges. And again, do a fairly brief overview that there are many challenges, not just in technology, but analytics and people. The technology challenges are of the sort that are introduced by volume, variety, and velocity. There are several approaches to technology. Parallel processing, you hear a lot more about that. Massively parallel processing and Hadoop-style processing, which is non-relational. So the two different models are kind of clashing, and there's this massive technology debate. But what we find is simple. It's not simple, but it's simply stated, is that no single paradigm works. There is no silver bullet for big data. That you need hybrid architectures that work together. And the challenges of how do you migrate from your legacy infrastructure to this hybrid infrastructure, that is really the largest technology challenge. I can answer more about this in Q&A, but let me move on to talent, because that really turns out to be a good lever in which you can increase the use of big data. So there's functional expertise and technical expertise are two things that you want to make sure you have represented on your team. In fact, if I were to summarize this slide, it's all about balance. You don't want to overweight your team to the technical side or the functional side, but you really need a balance of both. And that pie chart there is actually taken from a real project team composition that I was looking at in preparation for this, where there's a balance of project management people who are communicating with stakeholders and making sure milestones and deliveries were met. Analysis, so the data analysts, data scientists like myself who look at data and can make sense of it. There's governance, data governance, and then there's the technology, the people who know how to manage infrastructure, how to deal with distributed systems and distributed database systems as required for this, this kind of work. So how do you get started? Let me just quickly go over these without going into the details. So your roadmap has to be business-driven, not just technology-driven. We're working with places like the Grocery Manufacturers Association, which is trying to understand its challenges in a retail environment. What are the things that are affecting their margins? How do they better understand customer behavior? And going from that backwards to the analytics and the data that is required to understand that. Foundational data management capabilities like data governance and data quality do not go away with the advent of big data. In fact, you have to extend traditional techniques to encompass new notions of metadata, unstructured data, data that you don't own. Analytics, I keep talking about what did happen, the traditional reporting, why something happened, using BI to understand what's correlated with what, as well as foresight, what will happen or what could happen, and trying to use predictive models. Analytics can be used in a variety of capacities. Don't just assume that you have to have the most advanced analytics possible out there, but really try to take advantage of analytics as they are appropriate. Use data visualization in appropriate ways to communicate analytic results and to give people a sense of what is going on. Those people that may have been out of class the day that they were teaching math or stats will relate to a picture much better than they will relate to equations, believe me. Plan for quick deliverables, that is, deliver early and often. So people do not have the patience for projects that will take years. Develop a proof of concept, get something going. And in the last thing there, perform pilots to learn, to iterate, to be nimble. You never get it right the first time. So be prepared, like making pancakes, be prepared to throw the first one away. You will do the same thing with big data analytics pilots. And, but by iterating it, success is a series of small wins along the way. You will get much more results in the end. So with that, I'm going to conclude and with a few points. Remember, there are no industries that are going to be untouched by these trends. We have not found one in our work with clients. Even if they don't use data right now, eventually they will. The transformation does not just require technical whizzes who know algorithms and code, but also people who can get things done within an organization, who know how to hire the right people and assemble good teams. Ultimately, it's in fact not about the best algorithms or the fastest infrastructure. It's all about making better decisions. And finally, you have a historic opportunity here. There are a lot of trends that are coming together. The availability of data, the new technology, the new competitive pressures in the marketplace. The climate is just right for making changes with big data. I'm looking forward to seeing what you can do. Hope you take advantage of it. Thanks for your attention today.